Hi, this is Rick for EDU Mobile. Now we're going to talk about most of the control structures that we have in Swift. And these are the if and the for each loop, the while, and the do while. So we're just going to talk about the control structures in the context of using a Swift array. Now, we're not talking about arrays and Swift dictionaries in detail, but we will do that in the full iOS course. So let's go ahead and get started. First of all, I've declared an array of grades. Now, the way I declare an array of grades is to put the type in square brackets as if I were going to start subscripting the array. I could also just go ahead and put the subscripted array here inside these square brackets instead of the word double. Now, arrays in Swift are collections, just like they are in Objective-C, of either objects or primitive types. That's different than Objective-C. An NS array, for instance, in Objective-C, these have to be object types. But in Swift, an array can either be of type double, as we see here, or of instances of classes, or whatever we want. But in Swift, all of the elements of an array need to be of the same type. So this is why if we declare an array in this way and then later populate the array, I need to declare the type that this array is going to be. So enough said about arrays for right now. As I said, in the full iOS course, when we start with the Swift programming language, I'll fill in the details about Swift arrays and dictionaries and how they are both like and unlike NS arrays and NS dictionaries. I will say one more thing, however. In Objective-C, we know that an NS array is an immutable type, whereas if we want a mutable array or collection, we need to use the NS mutable array or NS dictionary, mutable dictionary, or NS mutable set, or so forth. In Swift, if we declare this to be a var, it is a mutable array. But if we declare this with let, it is immutable. And we need to assign it, and then we can use the elements of the array in a let array, but we can't alter them. So therefore, it's an immutable data structure. All right, so first we're going to look at an if statement, and here we're just going to determine whether we have the proper amount of grades. So we're just going to see if the count of grades is less than 6, and we have a very nice little method here called .count, or it's actually a property of a Swift array. .count gives us the number of elements in the array. So if this is less than 6, we're going to say there's not enough grades, and if it's greater than 6, we have too many. But if it is equal to 6, we have just right. We have all grades in. So for instance, if I add right now it's saying I have all grades in. Let's say I add another grade, 94. We're going to see that it will say too many grades. Likewise, if I delete 3 grades from it, I have now 4 grades and I have not enough grades. So let's make it just right again. Let's say 70 or 57.3. And let's add a perfect score in there, 100. Okay, and again, we've got all grades in. So the if statement, notice that unlike C, we don't have to take this Boolean condition and wrap it in parentheses. Also notice in Swift in general, we don't have the semicolons at the end of statements. We can put them in, but a semicolon is a statement separator, not a statement terminator. So if we want more than one statement on a line, we must put a semicolon in between them. Otherwise, we don't need the semicolon. So we have if and else, any of which other than the if are optional. And we set up a grade alert here and just set that grade alert string to not enough grades, all grades in, or too many grades. So the if statement is very straightforward. If you're familiar with C, it looks very similar to the C if statement. We also have a counted for loop. Here I'm just going to tell the interpreter that I want to just see what the value of grades sub I is. Again, I don't have to wrap the conditionals here in parentheses. I just need to declare a new variable for the counter, I equals 0, I is less than grades.count, and I plus plus, and then I'll subscript grades and get the result out. And I can see that result by looking at the timeline, as we've shown before. So for each value of grades, here we are over time. We can also scrub this little handle back and forth and see what the particular value of the grade is at any particular given point in time. Okay, so let's close the timeline and keep going. Now we're going to calculate an average, and one way to, for each. For each, let's just sum up all the grades, and we can just say for grade in grades. Don't we have to say for double grade in grades or grade colon double? Well, we could, but the type of double isn't, or the type of grade is known because all Swift arrays must be of a single type. So we already know it's a double. So the interpreter in this case, or the compiler in compiled code, figures out that grade is a double. And here I'm just going to take a double sum that I've set up 0.0, which says, okay, I'm a double, and then add it to grade, and I'll see that that happens 6 times. And then I will see that sum growing up, sum plus equals grade here, and I can see that happening. And then we'll just take that sum and divide it out by the number of grades and call that average. So average is equal to sum divided by grades.count. Now grades.count is an integer value. If I try to divide a double by an integer, what do you think would happen? Well, it turns out that there is not implied typecasting in Swift, and this is actually saying double is not convertible to an unsigned integer of 8 bits. So that's not going to work. So I do need to wrap this up in the double constructor. And now I get 84.6 for my value. Great. Here's a while loop. A while loop is while and then the condition and then the body of the loop. So a while loop will execute only if the condition is true. It will never execute even once if that condition is false. And this is important because we also have a do while loop. So the while loop, we just set up a loop counter equal to 0, and this loop counter is an integer. And then we have a high grade, which is a double, and it's set equal to 0. Now, we could have said that high grade is just merely equal to 0.0, and that would force it to be a double, and that's equally valid. So we're just saying that while that loop counter is less than the number of grades that we have, if the grades sub the loop counter is greater than our high grade, which right now is 0.0, we set the high grade equal to the grades at the loop counter. And of course, this is going to find that high grade for us. And then we increment the loop counter. In a counted for loop, the increment is here, not in the body of the loop. But in a while loop, we must have the increment inside the loop counter. We must have the increment inside the body of the loop. Finally, we're asking it to tell us what that high grade is. Here's a do while loop. It always executes at least once because the condition is at the end of the loop. And we're really doing the same thing here that we did up here. All we're doing here is we're looking for the low grade, and we're going to go through, we're going to loop through all of our grades and find the lowest grade, and then at the end we'll print it out here. Okay, so we have these basic control structures. They look a little bit different than the equivalent C control structures, but really they function in exactly the same way. Thank you very much.